So in the last video, I made the case for why hydrogen might be wonderful and very useful. Now I'm going to make the argument against hydrogen. And hydrogen has three major disadvantages. Storage. It's really hard to store and transport hydrogen. Price. Currently it's very expensive. And the opportunity costs. Are we going to waste huge amounts of money on this very complicated, expensive stuff when there are cheaper, better alternatives elsewhere? So let's look at storage. Hydrogen has a lot of energy per unit weight, 120 megajoules per kilogram, but it's a gas with a very low density. So in terms of energy per unit volume, it's crap, it's awful. Now this may not be a problem in some situations. You can have huge tanks of hydrogen in a outback field somewhere, but it's a real problem for aircraft or cars. Hydrogen gas is just so low density you'd need like a whole airship dangling behind you to supply your hydrogen. Also, because hydrogen molecules are so small, they tend to escape very easily, and they can worm their way into metals and make the metals brittle and tend to fail. In the early days of spaceflight, when they were first trying to develop hydrogen rocket motors, this was a huge problem. The hydrogen would corrode things and escape and cause fires, and it's a corrosive, hard to contain, and of course it's highly inflammable. Hydrogen used to be used for airships until a few disasters like this made it very clear that maybe hydrogen was not a very safe thing to use. So how can you actually store hydrogen in a reasonably compact form? So one option is to pressurize it. If you can leave it as a gas but pressurize it, well, you can do this. You can pressurize it up to about 700 atmospheres is what's typically used. But that takes a lot of energy to squish the hydrogen up to these enormous pressures, and then you need a very strong gas tank to hold it in, at which point the advantages of hydrogen are not there anymore. Having to compress it so much is going to take more energy, and it's no longer so lightweight if you have to put it in this huge, heavy, highly pressurized tank. And of course it's a danger. Pressurized tanks can explode. Another possibility is to liquefy it, to cool it down enough it turns to liquid. This is what works for methane, that is shipped from Australia to Japan and other countries by cooling it down and keeping it as a liquid. But unfortunately you need to go below about 20 Kelvin to liquefy hydrogen. That's very, very cold. That's going to take a lot of energy to cool it down that much, and a lot of energy to keep it cool, a lot of insulation, or once again a very big pressurized tank. So possible, but not going to be cheap and not going to be easy. A third option is to combine the hydrogen with something else, like carbon or nitrogen. You could store it as ammonia by combining it with nitrogen, methane by combining it with carbon, or methanol with carbon and oxygen. Now all these are possible, and they can then give you fuels that are more familiar, like methane is basically natural gas. What you could do is, for example, take carbon dioxide and capture it from the atmosphere or capture it from some chemical plant, and then combine it with the renewable hydrogen and make methane, which is then natural gas, which can be sent to our existing natural gas infrastructure and existing natural gas tanks. Or you could produce methanol, which could be used as fuel for aircraft and so on. So this has the advantage of making the renewable hydrogen easily transportable using existing infrastructure, but it certainly adds cost and complexity and drops the efficiency of the whole process. So pluses and minuses.